There we have medium problem. Given the string with digits, we want to find for each query left and right border, we want to find the sum of digits multiplied by the number that is a result of the cut of the string substring to int. And also we have to avoid zeros. Let's look at the code. Let's start with some algorithm. The brute force wouldn't be accepted because the number of digits 10 to the power of 5, number of queries 10 to the power of 5, parent square algorithm would give time limit exceeded, and we can't do the substrings in each query. We cannot do this because each query can be entire substring. So we have to do some preparation. The first idea is that as we have this sum, this is a simple, we can do prefixes, prefix sum. Basically we have a long string of digits, and for each we compute the prefix like this: 1 plus 2, 3, 3 plus 3, 6, 10, 16, and so on. This is the sums, and then we have to compute this second part, which is a substring. Let's call it x, and we have this is not very simple because imagine we have this substring as a right border, so this is a right, and left would be this on 2. So we have this string, r is 3 and left is 2, and we store in the x prefixes, we store for each result for each ending position. So for the x r it would be 1, 2, 3, and for the x l or l minus 1, because we're doing substring, it is just 1. So we cannot do simple minus operation because this is this have to be shifted by the powers of the difference. So basically this is the left this is left times 10 to the power of right minus left, and this is a right, this is a right minus, this is the formula. And as we have very long strings, so r minus l can be 10 to the power of 5, it would be 10 to the 10 to the power of 5, very big. We do model operation. The model operation can be pre-computed like tens when we have these powers of 10. We can do pre-compute this modular. So each time we do the times 10 model m, and we store it in some powers. Let's look at the code. This was my accepted solution. I did some debugging and I did some obvious mistakes because we cannot do prefix sums. Basically we have to do prefix power, and unfortunately we have only 10 to the power powers of 10, so we can do this modular pre-compute the models instead of do the inverse mod power. Okay, let's look at the shortest version of this code. It's basically the same idea still, because it's hard to do it in a different way. Maybe segment trees, I don't know. So this is a Rust. I put all the arrays in a single vector and just compute. By the way, this is last, this trick to shorten the code. And let's look at the Kotlin one. This is a Kotlin one, and this is yep, the same story, nothing interesting. Okay, that's it for today.